Hello, good morning. Today we are delving into the fascinating world of software testing with a special focus on the renowned testing framework JUnit. Our project aims to explore how JUnit facilitates the creation and execution of test cases, ensuring the reliability and robustness of our software. But first, let's meet our team. Our team has 7 members: Priyanshu, Nilotpal, Himanshu, Ayan, Gaurav, me, Shubhangi, and Avdesh.
Together, we will embark on a journey to understand how JUnit revolutionizes software testing. From test-driven development to parameterized test and exception handling, we will explore the various features and capabilities that JUnit offers. As we dive deep into JUnit, uncovering its nuances and mastering its functionalities, whether you are a seasoned tester or a newcomer to the world of software testing, there are something valuable to learn in our exploration of JUnit. Stay tuned for practical examples, insightful discussions, and a deeper understanding of how JUnit elevates the quality of our software.
Annotations in JUnit are essential metadata markers that guide the testing framework in executing our test suite. The @test annotation, for instance, flags a method as a test case, allowing JUnit to identify and execute it during the test run. Alongside @test, we utilize annotations like @before and @after to denote methods responsible for setup and teardown tasks, ensuring consistent test environments. These annotations not only enhance code readability but also facilitate the automated execution of test cases, making our testing process more efficient. Annotations are metadata markers that provide instructions to testing frameworks. In the provided code, we see annotations being used to define the structure of the test class and mark methods for specific purposes. Here, at the run with parameterized class, annotation indicates that the test class will run parameterized test, while @test before and @after are used to mark test methods and set up teardown methods respectively.
Assertions play a critical role in verifying the correctness of our code behavior. In JUnit, assertions are statements that validate expected outcomes against actual results. Leveraging assertion methods like assert equals, assert true, and assert false, we establish criteria for success within our test cases. For instance, we can assert that the result of a mathematical operation matches our expected output. These assertions act as checkpoints enabling us to detect regressions and ensure that our code functions as intended across different scenarios. Assertions are critical for validating the behavior of our code. In this code snippet, we use assertion to compare expected outcomes with actual results obtained during the test execution. The assert equals method, for instance, check if the expected result matches the actual result obtained from the evaluating an expression. This assertion verifies that the addition operation produces the correct result.
Test runners serve as the execution engine of our test suite, orchestrating the invocation and evaluation of test methods. JUnit 4, one of the popular test runners, provides a robust framework for running our test cases seamlessly. It offers features like parallel execution, test suite aggregation, and integration with build tools and IDEs. With JUnit 4, we can execute our test on the command line or integrate them into our contiguous integration pipeline, ensuring thorough and reliable test coverage. Test runners are responsible for executing test cases and generating test reports. Here, JUnit 4 serves as the test runner for our test class. It manages the execution of test methods and provides integration with the testing framework. By running the test class with JUnit 4, we ensure that all test methods are executed according to the defined annotations and
Parameterized tests enhance the scalability and flexibility of our test suite by enabling execution of the same test logic with multiple input values. Through annotations like parameters and test data providers, we can define a set of input parameters for our test methods. For example, we can validate a mathematical operation against various operands combinations. Parameterized tests reduce code duplication and improve test coverage, allowing us to validate our code against a broader range of scenarios. Parameterized tests allows us to run the same test logic with different sets of input parameters. In this code snippet, the test data method provides the parameters for parameterized tests. Each array within the collection represents a set of parameters for a single test case, allowing us to test the addition operation with various component
Suits provide a
combinations.
systematic approach to organizing and executing multiple test classes as a concept unit. By grouping related test cases into suits, we can streamline the execution of our test suite and maintain better test organization. Although not directly utilized in the provided code, test suite can be created using annotations like run with, and suite. These annotations enable us to aggregate test classes, define execution order, and apply custom configuration, facilitating efficient test management and execution. Test suites enables us to organize and execute multiple test classes together. While not explicitly used in the code snippet, test suites can be created using annotations like run with, suit.class, and suit.suit classes. By grouping related test classes into a suite, we can execute them as a single unit, facilitating efficient test management and
Timeouts serve
execution.
as a safeguard mechanism to prevent our test suite from hanging indefinitely due to long running or unresponsive test cases. With the test timeout annotation, we specify a maximum execution time for individual test methods. If a test exceeds the defined timeout threshold, it is automatically terminated, preventing resource contention and ensuring the timely completion of our test suite. So timeout management is crucial for maintaining the responsiveness and reliability of our test environment. Timeouts help prevent test suite hangups caused by long-running or unresponsive test cases. By specifying a maximum execution time for test methods, we ensure that tests complete within a defined time frame. As you can see in the code snippet, the timeout annotation sets a timeout of 1000 milliseconds for the test long execution time method, ensuring it completes within 1 second.
Exception testing validates our code's robustness and error handling capabilities under exceptional circumstances. By annotating test methods with test expected or using assert throws, we verify that our code behaves as expected. When encountering specific exceptions, for example, let's say, we can validate that a division operation throws an arithmetic exception when dividing by 0. Exception testing ensures that our code gracefully handles error, enhances tolerance, boosts overall software reliability. Exception testing validates the error handling capabilities of our code. So here we use annotations like @test expected to verify that specific exceptions are thrown under certain conditions. The test division by 0 method, for instance, expects an arithmetic exception to be thrown when dividing by 0. Exception testing ensures that our code gracefully handles errors, enhancing its reliability and robustness.
By delving deeper into the technical intricacies and practical applications of each feature, we can gain a comprehensive understanding of their significance in JUnit testing. Here is the practical implementation of the coding where we are using the Eclipse IDE and we have incorporated the JUnit module in order to run our test cases. Now, when we try to run the full test coverage, we are given the required results and we hence achieve the running of all the test cases automatically, and even a slight change could be detected and automatically be tested here.
As you can observe, the required results has been generated. It shows the required test runs and the test case results.
Now the ID also shows the coverage range for the following code snippet. Green explicitly tells the successfully executed code region, where the red describes the regions we are facing errors in.
In conclusion, we would like to express our gratitude for the opportunity to delve into the realm of JUnit testing through this assignment submission. Our exploration of JUnit has been enlightening, showcasing its pivotal role in ensuring the reliability and robustness of Java applications.
As we wrap up this assignment, we extend my thanks to all our team members and Dharmender sir for their collaboration and support throughout this endeavor. We are confident that the knowledge gained from this project will serve us well in our future software development endeavors. Thank you for your attention and consideration.